Today, you're going to learn how to build an electromagnet. For the experiment demonstrated in this video, you will need the following materials: a 9-volt battery, copper wire with the ends stripped, iron nails, and paper clips. You may be wondering why you should care about building an electromagnet. Well, first of all, this experiment demonstrates the principle of electromagnetic induction. It is called electromagnetic induction because, as we can see, we have electricity in the first half of the word and magnetic, referring to magnet, in the second half of the word. Electricity induces or causes magnetism. This principle is actually the reason many of our electronics work, anywhere from cell phones to electric guitars. Here are our materials. We have a 9-volt battery, a copper wire with the ends stripped, iron nails, and paper clips. We start out by taking an iron nail and wrapping the copper wire around it. We want to do this very tightly in order to get a strong magnetic field. Once that is done, we connect the ends of the copper wire to the ends of the battery. That would immediately result in the magnetization of the iron nail. Be careful when connecting the copper wire to the battery, as the battery may get hot. As you can see, the iron nail is now behaving like a magnet and has the ability to attract the paper clips. This is the setup for the experiment. We start out with a battery and an iron nail. We connect one end of the copper wire to the positive end of the battery, and we bring it to the iron nail and wrap it around it as tightly as we can in order to get a stronger magnetic field. We then bring the other end of the copper wire to the negative end of the battery. This will create an electromagnet. Let me now show you how this works. First of all, you may be wondering how your common household magnets work, such as the refrigerator magnet in your wall. Well, the way these magnets work is they have a north and a south pole, with magnetic field lines going towards the south pole and away from the north pole. In this way, these magnets can attract different metals, such as iron or your refrigerator wall. Now, when we have a loop of wire, such as the loop of copper wire in the experiment, and then we connect to a battery, there causes electricity to flow through it, as shown by these arrows right here. Now, when we have the electricity flowing through the loop, that will also cause the magnetic field lines, just like the ones we saw in the magnet. Moreover, this loop can also attract metals, such as iron or the paper clips from the experiment. We loop the copper wire several times because a single loop by itself is not very strong. However, when we put a bunch of them together, the magnetic field set up and it creates a stronger magnet. Now, you may be wondering, what does an iron nail have to do with any of this? And why do we put it inside the copper coil? Well, you may not know this, but iron actually has a lot of tiny little magnets, which all point in random different directions. You do not see this because, since they all point in different directions, the net effect adds up to zero, and thus iron by itself is not magnetic. When we put the iron nail inside the coil, which itself has a magnetic field, however, all the little magnets inside the iron line up. Because, as we have observed before, magnets attract each other or repel each other depending on their orientation. Now, when all these tiny magnets in the iron line up, it creates a larger, stronger magnet inside the copper coil that allows us to attract the paperclips in the experiment. One of the reasons the magnet in our experiment wasn't very strong was because the electricity we were able to get out of the battery wasn't strong either. Don't play around with high levels of electricity, as that may prove dangerous. If you want to get different types of magnets, you can experiment with different shapes. Instead of using a straight nail, you can get a circular hoop of iron, such as a washer. Wrap the copper wire around it as you would have with the iron nail, and see what kind of magnet you get. Have fun experimenting!